where he's responsible for leading the group's product and technology roadmap and strategic development. He also represents the group as board member of Links Analytics and Bino Labs. So in the first part of this talk, Dr. Zhang will talk about 3D visualization with spatial data for 5G planning. And then the second part of this talk, we'll have another two speakers, Mr. Alex Zhang and Mr. Chris Chen. So Chris is the data scientist in HKT, and Alex is the head of data science in HKT. He's responsible for developing new analytic products and platforms for support the club's business partners. So in this second part of the talk, they will talk about website auto-tagging algorithm. So let's give a warm welcome to our speakers. Thank you.
Hi, good morning, everyone. Hi. Thanks, Gotti and Sammy, for accepting our proposal. I'm very glad to be here and see all of you here. I guess a lot of you are Python developers. I actually joined the PyCon 2018. I think that was in Cyberport. That was a really good one, and I hope you have a very good day today as well. But that has been quite challenging in the last few years for everyone. Good to see you guys. So I'm actually from the Group Technology Office, and Alex and Chris from the Big Data team. But to start with, I just have one slide to introduce us. A lot of friends here, they know Navigator for broadband, CSL for mobile, Now TV, maybe for World Cup. But then we actually have lots of digital business. Just like FinTech, we have Tap and Go, Faxi, Mox Bank. And MedTech, we have DrGo, and loyalty e-commerce, we have Cup Shopping and the Cup loyalty program, as well as we have the content, the media, Move, Blue Whale and Yellow Whale, the video streaming. The Yellow Whale is actually the largest streaming service in Southeast Asia, even bigger than Netflix. So we started the digital ecosystem journey quite a few years ago. Maybe some of you don't really know they are actually under PCW or HKT, but I want to tell you that there are lots of activities, development, data analytics within the company to support all this digital transformation and offering. So I'm very excited to share with you all on two topics today. One by me, more on 3D visualization for spatial data for 5G planning, and then my colleagues will share the other one. Okay, so quick, I probably keep myself 10, 12 minutes. What is the 5G mmWave and how we did a project for mmWave rollout in next few years, and also the outcome for the analytics from Python, as well as working together with the government spatial data, and the end, hopefully give you some inspiration for new application for smart city. Okay, so this chart is is about 5G. 5G coverage. So we start 5G 2 years ago, and many of you, may have changed, from 4G to 5G, and the coverage in Hong Kong for 5G is probably top in the world. 99% for the whole Hong Kong, 99.9 for the urban area. But 5G doesn't stop here. 5G actually evolving. There are different releases coming up. Say, for example, release 17, release 18. Just give you an example. In the future for 5G, there will be dense cell or ultra dense cell, so they are very small, that can serve even higher capacity. So if you have some super high 4K video or even 8K video, that can support that, or super low latency for your video game playing or multiplayer gaming. That's possible with the next generation of 5G. Also, an example is beamforming technology, MIMO, that kind of thing. So that can improve the capacity, for your mobile phone with the base station. But then my point to highlight here is there's something called 5G Advanced. Maybe you will see that in a few years. There are lots of things called, private network, network slicing, or mmWave, which, I think we haven't unlocked the full potential of 5G. A lot of you guys may have 5G now, but still using YouTube, WhatsApp, that kind of things, right? But there are actually more application or enterprise services can be supported by 5G and next generation 5G. So some people talk about 6G right now. I think that's a bit longer, probably in 10 years. So to start with, what's wave? Wave basically millimeter wave, and it's high frequency 5G. So the official definition is 30 gigahertz to 300 gigahertz. But in Hong Kong, the OFCA, the Hong Kong government licensed the wave at the frequency of 26 gigahertz to 28 gigahertz, and which we got that. What you are using now for 5G is around 2 to 4 gigahertz only. So if you think about higher frequency, basically mean higher data rate. That transform more information to your mobile phone. Okay, but there's a limitation for wave, which require the line of sight. I think most of you study physics. You know the wave can, diffraction, refraction, that kind of things, right? But for wave, you need the line of sight. So you have to get your mobile phone, with a straight line to the base station, then you can get that wave. Otherwise, you can't. And it can easily absorb by moisture or blocked by trees, whatever. So if you think about deploying wave in the city, it will be very expensive because they are very small cell, and you need many of them, in the city. So so my will is we won't get wave for the whole city, but that we will have some special area with wave. So I'll give you some example of base station. Typical base station is up the building. You see my colleagues looking at them. Well, we're actually flying drones to help the maintenance, and that's supported by the 5G video streaming and low latency, so they don't need to come up the building and look at the base station. But that's another story. So usually those base stations is facing down to the street, and they have certain angle to cover, the area around that. However, you can't put your base station everywhere because there are some regulation or there are some property management issues that you have to take care. So in our exercise, we pick 50 4G cell site and see if they worth the money to upgrade to wave for 5G. Okay, very luckily that Hong Kong government actually released a very new set of data called Dual Data Store. You can get it from the government website. And because of that, we have the 3D model of the Hong Kong. And that's why we can calculate in an outdoor environment if there's an out of sight, is there a light of sight that we can support the user. Okay, so you can see the first step is basically get the data from the government, and then we convert that into PLY format. It's a bit trouble to convert that, but there's some process you can handle that. But from there, we try to make from the base station the cones, which representing the 5G signal, and see how wide they can cover. Okay, so there are a few libraries we use in the project, NumPy, Math for calculating the volume, Open3D for the visualization, of course, pandas. I won't go through the details, but the key concept is after creating all the cones and calculate the volume, we have to measure if those volume actually overlap with the building nearby. So if those buildings, being overlapped, we have to cut that part, of the cone. Okay, but then that's quite trouble. So, by calculating the 3D things, with all those. So that's why we turn that into dots. So we downsample that, and we turn it into, the point cloud, just like right-hand side down there. And then we count the dots, see how much coverage, that bin going that direction, can still offer to the user without being blocked by any buildings or obstacle. Okay, so from my view, this is one of the examples down there. From my view, it's kind of a proxy or approximation in the real world because, if some of you study information or electrical engineering, wavelength is very hard to model. A lot of people attempt to model the wavelength, the wireless model, but never get very accurate because they're so different parameter affecting, the actual reception. So we can only take this as a proxy, as a scorecard to estimate where we should, upgrade the 5G. Okay, I can't play this video, it never worked, but you can get a sense that, after you have done all the things, you can have the 3D model and that can, you can turn it around, up and down, vertical, and see whether this is right or not, or that area being blocked by many buildings. Show you another picture here. This is more Happy Valley on the right-hand side with better coverage. So you can visualize the difference. I think this is quite helpful for engineering colleagues or even business colleagues to make the decision. And this is a business outcome. I hide the site code on the left-hand side, but then it can turn into a scorecard, say, okay, how much traffic, how much handover or user in that area in average, plus then what is the coverage of the cones, the volume, then we can score them together for ranking for a future upgrade. Okay, so but having said that, the first part for Wave upgrade in 5G is still mainly indoor. I think the next stage is going to be outdoor, but that may maybe 2 or 3 years later. Okay, so I really want to say that database is amazing. They solve a lot of work a company has to do, and actually it's free. And so I think that can help to push the imagination of smart city application as well. Some items are listed below. For example, urban planning, business location of retail store, if people walking around that street more, and transport planning, modeling, exchange, as well as I think the final one is quite interesting. If you have the 3D model, you can actually think about if I can plan my drone flying track, or if I have a property, or I'm interested in a property, whether that property has a good vision of sunlight or that kind of vision, that can be done through the 3D model. You can use Google Map now, but I don't think Google Map opened it for you to do all this mathematics and Python coding. Okay, so take a look at this website, Geodata Store, and they match with all this education, environment, technologies, transport, open data by the government. Okay, before I pass my time to Alex and Chris, I want to say, we have lots of digital offering across the company. So if anyone of you interested, or you're a student or final year student, feel free to talk to us. We are just outside in the booth. We hire internship, summer, winter internship as well, and keep that email. That's a fast track application. If you are interested, just send your CV there, and we will find a good colleague to let you know if we have some interesting posts. If you are not interested in that, we still have the Move, music coupon discount. I found it especially special for this PyCon conference. So feel free to grab the leaflet outside. So thank you, and pass the time to Alex and Chris.
Good morning. Chris, come on board. Thank you, Chung. So after Chung shared with us all the interesting information about the 3D virtual data building, we actually want to talk about consumers, everybody in the audience, you and me. We actually, we are part of the data science team in HKT, so we analyze customer data, and then we try to provide better services to our customers. One of the business that Chung showed us earlier, we have a business we call HKT Club, which is the loyalty program. So anyone is a part of the HKT services, you can join automatically you're part of the club member. Or you can join club even if you don't have any business or services with HKT. So the benefit of the club, you get points when you spend, you buy from what we call club shopping, travel, or insurance. Okay, so on our shopping site, we have it's actually traditional classic problem we're trying to solve. We know our customer shopping behavior on the site, okay? But we want to provide better services. A lot of time that customer coming to the site, they browse, a couple of items, then they leave, or they put on a shopping cart, or they forgot about their shopping cart, okay? So limited information we actually gather from the behavior on our shopping site, okay? So what we really want to know is, thank You're so kind. Okay. So in addition to the behaviors on the shopping, our shopping site, we also like to have a broader understanding in terms of sites they're browsing. So we have a better interest understanding of our customers, and the objective is to provide better services. So the old approach is when we classify a website, mostly it's just by keywords. And then nowadays, a lot of keywords are really identical, so we can't really differentiate website about exactly the contents and also the interest of our customers. So Chris will share with us today a different approach that we tried and some initial results that we can share with you. Okay, Chris, thank you.
Thank you, Alex. So for this, so our goal is to identify the website in the internet to see what those websites is about. Maybe you are running an e-commerce, like some beauty products you are selling, and if you want to know, like recently there are some websites that is related to beauty, and they are also selling similar products, and they are getting attractive and more popular in different forums or stuff, then you will probably want to know that website exists, and and then you can analyze your competitor. So to doing the automation, like because the internet is so large, there are so many websites, and people are using different words to classify those, to label their data or describe their products. So we want some intelligent stuff to help us to automatically annotate the website. So basically, we try few approach. The first one is we try to do it like ask the model to look at the websites unsupervised through some topic modeling to see what those website is about. Like we give it all a lot of websites, and he help us to group the websites itself. Like you will say maybe some websites is about the beauty, and how can we know when the model tell us there are 10 websites, how accurate it is? Or maybe the model is like 60% accurate, how can we improve it? So we abandon the unsupervised approach, we turn to some supervised approach, like text classification. But when we are talking about classifying in the websites, there are lots of different business use case. Like this time I want to know beauty, next time I want to know why, and next time maybe golf or other sports. There are a lot of different topics we want to know. So if we are doing some text classification, we don't want to do a lot of labeling of different websites. So in this case, we want to have some using some pre-trained model that maybe encode some language stuff in the model. Like the fast test one, you try to ask the model to go through all the test documents that are available and learn the test within those documents. Like you will learn maybe say you have some sports website and you will be linked to certain keywords like sports shoes or other like badminton or those keywords. They will all link to the same, they will be encoded to similar meanings. But so use this fast test library, we achieve maybe the accuracy 76%, but that's not enough for us because we want to, like the internet is so large, we want to filter the websites as accurate as possible. So we further go further, we use some pre-trained transformer model. What's the difference between it and the previous fast test? The previous fast test tried to encode the meaning of a single word. And the transformer model tried to encode the meaning of the whole document. And with this model, we are able to achieve a better accuracy. Like I will use around, we will improve it from 76% to 90 something. And if you imagine it's like we filter, say, from millions of websites, and we reduce the wrong websites by 20%. Then you don't have to look at those wrong websites again and again. So this is some background of the model, but if you go to the internet and search transformer, then you will get a lot of this information, so I will skip it. But so let's go to how we implement it. Talking about those states of art or model, maybe you maybe have some learning, but actually there is a very good Python library called Hugging Face. With this library, they provide the API for you to implement different states of our model, like with few lines of code. Like I will show you how easy it is. In our case, for training of the model, you just like 26 lines of code, and for prediction of this model, you only need 20 lines of code. It's really easy, and it's not just about the classification. It's also about maybe you want to build a chatbot. If you want to do some summarization, you want to do some image generation, all this you can do with few lines of code in Python and with the library. So yeah, we finally achieve a good accuracy, and we can classify the websites in a very good. Like we know some colorpop.com is about beauty and fashion, and because we also have how popular each website is, then maybe if you have a e-commerce like selling beauty product, you will know, yeah, recently there is another website about beauty and it's rising its popularity, and maybe you want to have a look on it. Okay, so, but that's not the end of the story. When we get the model, we have the result, but it's also about building the whole systems for our business user to use it. So to implement it, in addition to Hugging Face, we actually have a lot of stuff. Like we use the Scrappy to get the new websites, content of the new websites. We have, say, for just like I've mentioned, for e-commerce, sometimes you care about the golf, sometimes, like recently, you care about the phones. Maybe next time you want to know more about the some camera stuff, so you have to keep calling the internet. We are using Scrappy to do it, and then after you get all those websites, you want to do some analytics, we use PySpark to do the analytics. And using Google Cloud, it helps us to make all the implementation easier, and we can have a better control of our resources. So this is a detailed implementation. Imagine from the first part, the business may have a server website that is related to the things that they care about. Then they just have to call the cloud subscribe through maybe a API, and then they can get those links to us, and then we help them to scrap the result. And then we will do the model training on schedule model training task, and then do the ML ops with Vertex AI. And finally, with the final result, we also do the analytics in Spark and using it to provide some insights to our business user. Yeah, so this is the key takeaway from my part is we build an automated website classification for competitor alert. And we also use the pre-trained language model to get a very good classification result. And even with small data set for small, it's dozens of websites or hundreds of websites, and then it will help you to identify all the results, maybe for millions of websites. And the final one, Hugging Face provides you a good API that you can implement some good models with maybe 20 lines of code. Yeah. So finally, the most important message. Yeah.
Feel free to talk to us technically, whatever in our booth out there. We're at the very back or at the corner, so yeah, don't hesitate to talk to us. And
we don't have any gifts, but we are the gifts.
Yes, we are the gift.
Come to see us.
Yeah, and some stickers finally. So is that Q&A time?
Yeah, feel free to ask questions. Yeah, please, to the speakers. Yeah. Testing.
Hi. Could you turn back to the? I'm more interested in the first part of the presentation on the mapping bit. Could you explain briefly why you are on a distribution, on the wave distribution thing? Why are you calculating the cone volume rather than the area of coverage?
That's very interesting. Well, I think you can do that way. If you think about, not doing the cone, the volume, but just on the surface area, that's possible. I think that's a very interesting idea as well. But then we have to calculate. It may be a projection from the cone, but we have to find those dots really, on the surface. And I think that's a very good suggestion for the next enhancement. And that in the real life, it could be more sophisticated than that. We believe it's line of sight, but sometimes people actually try it. It can defect a little bit, and then that will change the model as well. So I think wireless modeling, especially for wave, is still a quite big, interesting research area. Yeah, even in academia. Well, at the end, I think we try not to rely on just the volume or the the dot points, but mix with other network data. For example, how many users actually stay there or use data there. If they pass by there, hand over, doesn't mean they use data. Then there's no point to upgrade that cell site. But if they are like outside the SOGO, they really stand there and then use a lot of consumption waiting for friends. I think that worth. But then you also ask the question if SOGO is quite straightforward for, I can think about that SOGO. But maybe there's some other places in Hong Kong that we didn't know, so we can take out from the data. Yeah, thank you.
Hello, I would like to ask for the second part because I'm quite curious to know how do you determine the popularity of the websites that you are going to look through? Because you said how do you put in the label for each website, but how do you determine the popularity of the website that you need to go through? Because you said you want to look at the competitors.
Yeah.
How do you know that who's your greatest competitors in this case?
Okay. It's actually, well, if you look at like popularities, we can look at like a number of visits and the duration of visits, so that easily we can identify that. We're not looking at like a specific competitors, because as a we're running a actually e-commerce and loyalty website. So we have, roughly speaking, in terms of our market share, we're like a number 4, number 5 comparing to like the bigger ones. So for us, it's more about instead of like going directly to so-called competitors, we're more focused on have a better understanding of our customers. We provide them with a better experience when they're on our shopping site, give a better like a recommendations. So that's our sole objective. Thank you. I spent a whole night last night practicing my Cantonese. I'm surprised that actually we all speak English here.
You can give it a try. You can give it a try here.
Yeah.
So any other question? Guys, close.
Is that in Cantonese?
Really Cantonese?
Of course, please, yes.
No, I think I stick to English is better. So I would like to know more about the implementation detail of the Scrappy and also like the training stuff, because like I have done NLP before, and I know that like using NLP and also the Hugging Face model can, like if I train with a very long approach and I have a very long corpus, and it will easily get overfit. So I would like to know like how many approach you have trained for the data, and I know that like for each corpus, the longest length is like 500 something. So like what information in particular for each website you have scrapped in Scrappy so that you can determine the text label for the website?
Yeah, interesting. Yeah, that goes to a very technical detail part. So yeah, for the Scrappy part, actually what we get is the content of that website. When we get the domain of the website, then we go to that website to get the content, and we will store the whole page, and then we will do some data cleansing stuff. And for the training part, it's about how to evaluate the model accuracy and also doing some regularization. Yeah, so the part that you are aware of is doing the, how to monitor the overfitting. It's all about the ML ops that I'm talking about. You will monitor the feature importance, monitor the performance of the model on some evaluation set. Like what I've mentioned at the very beginning, we will receive, say, maybe some websites that that is cared about. Then we will use that website. That website will relate to particular content. Then we will also have another group of websites that is unrelated, and use it as an evaluation set to see our model performance. And we will keep track of it with the ML ops provided by Vertex AI. Yep. Thank you.
So any more questions? I think we still have time for one more question. So if no, actually, I have a question for Dr. Chung. So just a stupid question, sorry. So the MM waves, you show the wave length is quite close to the microwave, right? Yeah. So would it like heat up my body when I use 5G?
Wow, that's very challenging question. As a mobile operator, the answer is no. Yeah, well, I got this question. I study wireless since 20 years ago. So I think the official answer is there has been quite a lot of attempts to study whether there would be physical, impact on human body. The answer is yes or no, or there's no answer. But recently, people ask, if that should be changed, or there are people talking about, this MM wave, they usually is transformed in very low power. There are restrictions, so they can't do that. But then, there are still people talking about if you want to see the impact of human body, it may take 20, 30, or 40 years to see whether it's true or not. But then, even if you have those data, the answer is still statistically not really significant. So I would say unknown, but then official no.
Thank you, thank you. Thank you, Dr.
Actually, I think the best way to protect yourself is to leave your mobile phone at home. Just don't carry it with you.
Well, my personal advice, when you sleep, don't put it next to your head. That's it. That's good enough. Yeah, if you have kids or babies, just don't put those wireless router or mobile phone next to them. Yeah.
Thank you, thank you. So thank you for the speaker. Let's give a round of applause. Thank you.
Thank you. Thank you, everyone.
Thank you. Thank you.
So up next, we have Kelvin to introduce our next talk.
Thank you. I'm not the speaker, sorry. I'm Calvin from Open Source Hong Kong. Before I introduce the upcoming session, I would like to check, did anyone watch the Marvel series about the What If? Yeah, because the topic is called What If, Python plus Azure. So this Python, for this topic, Python Azure innovation is more than a linear path. It's a prime of endless possibility where single choice can branch out to the limitation innovation with the Python. In this session, Ethan will be mastermind to showcase different use case scenario of implementing Python in various industry and domains. Join him to discuss the